One of the best things about researching the ancient world is that there is always something new to discover. You might think we already know everything there is to know about Mesopotamia, for example, but it turns out even the bricks of the ancient world still have something to teach us. According to a new study involving University College London researchers, ancient bricks inscribed with the names of Mesopotamian kings provided important information about a mysterious anomaly in the Earth's magnetic field 3,000 years ago. Scientists examining these Mesopotamian bricks recently discovered traces of the Levantine Iron Age geomagnetic anomaly that shed light on its power. Here it is. About 3,000 years ago, the Earth's magnetic field increased very dramatically, but our knowledge of this ancient increase is limited because it happened so long ago. The Earth's magnetic field weakens and strengthens over time. These changes leave a distinct mark on hot minerals sensitive to magnetic fields. By studying these Mesopotamian bricks, scientists have been able to learn more about the spire, and their research process is almost as fascinating as their findings. If Mesopotamian bricks can tell us anything about the Earth's magnetic field 3,000 years ago, it is in the way they were constructed. Small grains of magnetic rock were used to create some of the bricks, and neither the bricks nor the magnetic grains on their own reveal much useful information. To accurately investigate magnetic field strength, scientists took Mesopotamian bricks containing iron oxide and exposed small pieces to extreme heat before cooling. They already had some kind of built-in signature of the Earth's magnetic field from the moment they were created. So when the scientists reheated everything, they replaced the original magnetic field with one they created. When all was said and done, this allowed the team to compare the magnetic field originally locked in the Mesopotamian bricks with the magnetic field they created in the laboratory. What did the team discover? The Mesopotamian bricks they examined were first created when the Earth's magnetic field was 1.5 times that of today. This allowed them to effectively date the bricks as occurring during a time period known as the Levantine Iron Age geomagnetic anomaly. Interestingly, the same team first discovered this anomaly in 2009 and used the same basic method on rock layers that they would later use on Mesopotamian bricks. Their initial discovery confirmed the existence of the anomaly in question. Yet, until recently, there was no way to confirm exactly how strong the Earth's magnetic field is in this region. Now, having pioneered an innovative way of dating various minerals, the team hopes their work on these Mesopotamian bricks will completely revolutionize the field of archaeology. So why is the Earth's magnetic field changing? Earth's magnetic field is constantly changing for several reasons, all of which have to do with the churning liquid iron in our planet's outer core. This rotational motion creates electric currents that create the magnetic field. Here are the main drivers of the changes. 1. Fluid movements in the outer core. Liquid iron in the outer core is in constant motion, and these movements can change the strength and direction of the magnetic field. These changes can be small and gradual, or they can be large and rapid. 2. Temperature changes in the outer core. The temperature of the outer core is not uniform, and these temperature changes can also affect the magnetic field. Hotter regions tend to have stronger magnetic fields, while colder regions have weaker fields. 3. Interactions with the solar wind. The solar wind is the flow of charged particles blowing from the sun. When the solar wind interacts with the Earth's magnetic field, it can cause the field to fluctuate. 4. Pole reversals. Over a long period of hundreds of thousands to millions of years, the Earth's magnetic field can completely reverse, with the north and south poles reversing their positions. This is a natural process that has occurred many times throughout Earth history. 5. Polar wandering. Although the poles do not physically move, the position of the magnetic north and south poles is constantly changing. This is because the magnetic field is not perfectly symmetrical, and the strongest parts of the field can move over time. 6. Strength changes. The overall strength of the Earth's magnetic field can also change over time. Recent measurements have shown that the field has weakened by about 10% over the last 200 years. In summary, this discovery provides a historical map of changes in the strength of the Earth's magnetic field. Yeah, we've come to the end of the video. Don't forget to like the video and subscribe. Bye.